Hey, how's it going, everyone? Happy Monday. We're going to see if we can get our PyTorch. We'll use some PyTorch transformer to see. Here's the deal. Last week on Friday, we were using Rust to build a. Actually, where was it here? To build a transformer model. And look, I didn't feel like continuing that. It was just a little bit much. There was just a bit much. Like, look, if we're looking at this code here, I mean, just look. I kind of get what's going on. It's just a lot. It's just a lot trying to use this burn framework. I mean, this part's a little bit easier and more understanding to understand what we're building here. This is pretty straightforward. You know, I do want to go forward with it. It's too much. It's too much. I want something simple here. Look at this. Watch this right here. Check this out. All right. Look at this right here on the screen. This is what I want. This is what I want to deal with right here. Look, the four simple lines of code right there, right? You've defined the model. You've got your inputs and your outputs, and then you have the model try to see what it does. See what happens. See what the value. Although the input data and the source and target. Why would you put both source and target at the same time to get the output? What's going on here? Don't get me wrong. This is still a lot easier. This is far more straightforward. Hey, how's it going, Mohammed? Welcome on in. Happy Monday. We're doing more AI stuff with stock quotes. That's the plan for today. I don't know what else we're gonna do. So I figured we'd continue on this. We could do the Rust stuff. I have it over here. We could do the Rust stuff. So I've got it here. CD Rust lsvi dot period. Right. So it's right here. We could continue this. And I kind of want to, though it's not. If we do, we're not going to get to our goal. We're not going to get to test my idea as quickly. But maybe what we could do is we could go ahead and try it anyway. Maybe we could go ahead and just keep going because we made some progress on it. And with where it is now, I feel like I can make incremental progress. And I haven't ever really done this with the burn framework. So while I was, tempted. I'm tempted to jump into this right because look at the syntax right there. Isn't that beautiful? Isn't that beautiful? Hey, Geechee, what's up, Steven? We're doing good. Happy Monday. We're gonna do more AI today. We're gonna be using the burn library. Although we're looking at PyTorch right here, and it's so much nicer. Isn't it just so much nicer right there? Hey, Quantified Quantum. Hey, Torva. Good to see you. We're doing good. How are you? We're doing great. Thank you for asking. Good to see you. Happy. Hope you had a good weekend. We did. We had a good weekend. We had a good weekend of working on some infrastructure to improve the network's capability because we needed to do that. That's what we got to do. We had to do it, and it was a lot of fun. Actually, I really enjoyed it, and I'm very excited to see the upgrades that we performed on the network. To get deployed today. That's what I want. Wait, we doing quant now? I know, right? We're doing quant. All right, Torva. That's what I want to do. I was just kind of a little bit interested in doing. I'm sitting here right now. I'm looking at the PyTorch library, and it's just so appealing. And it's like it's just far more straightforward to deal with. I mean, if you're looking at this, like, look right here. Look at that. Isn't that great? Isn't that great? Look, push the data through the model. Boom, done. I love it. Isn't that great? But I guess we'll keep going on burn for a second here. We'll keep going on the burn. We'll see. We'll see what it looks like. All right, so here we go. Steven, want to do the announcement about what we talked about earlier, the hackathon stuff? Quantified Quantum, are you talking about the hackathon stuff? I'm pretty sure you're talking about the hackathon stuff. I'm pretty sure. Let me know. Let me know before I bump into it. So looking good dropout, and then a GLU linear out. What is this? Where's the GLU at? There it is. Oh, GLU4. Oh, that's the activation. And then you've got a dropout, and then you've got a linear output. Yeah, the hackathon stuff. All right, so holiday started. Hello, holiday started. Yep, we're starting the holidays. You got it. Welcome on in, you guys. Geechee Main B. All right, so we've got some hackathons going on right. We got a hackathon going on right now, where if you join in on Discord, you'll be able to see what are the rules under our hackathon channel. Check it out. Additionally, we want to, here's the hackathon channel right here. Here's the hackathon channel right here. And then you just click in there and you'll see hackathon. Additionally, we're thinking of doing regular hackathons on a regular basis. Quantified Quantum's talking about, some bigger ones like a few times a year and smaller ones a little more frequently in the year. And so that's kind of the idea. That's the idea. That's what we want to do. I thought it was pretty neat. I thought it was a pretty neat idea. So yeah, that's kind of on the table right now. It seems like a good way to, jump back into the community engagement, things like that, and ways to interact with you guys who are here right now. I think it's a great idea. I think it was awesome. Quantified Quantum, thank you for your inspiration on that. That was great. That was amazing. So hackathon, join the Discord, and there you go. There you go. Concept, please. Oh, the last attack. Concept of the hackathon this time around. Let's see if we can zoom in on it. What you? Oh, Wheelzack. Hey, Wheelzack, what up? How's it going? Good to see you. Welcome on in. Can we make a back test so we can see how well it predicted? Yes, we will. We'll do it. Geechee Main, we'll do a back test. That's what I want to do. We'll do it. So we're gonna do some. Oh wait. Yeah. Yeah, that's the plan. So we're going to be using the burn library. It's pretty okay. It's fine. It's just not as, it's got all these like little brackety things. It's like, what is this right here? What's going on here? Why do we need these generics? Why do we need these generics in here? So yeah, the hackathon here on our channel, it's your task is simulate a 4x4 CPU, a 4x4 CPU, normal 2D programming environment. Because the CPU is a third axis, each cell doesn't use normal binary bits. Instead, every cell can take. Let's see if we can zoom in on this. So no, wait, that's too far. Okay. So the idea is you'll create a grid of compute units, as far as I understand it, and then you'll leverage this compute unit grid in order to perform operations. And you can define these operations: ternary operators, unary operator. I don't think we did any unary operators, so and binary operators. And so that's the task. That's the idea for the hackathon. That's it. Hey everyone, welcome on in. Good to have you here. Hey man, yesterday I was sleeping around 4 p.m. when an earthquake occurred. Both of my hands were in my pockets. Because of the earthquake's jolts. I almost read it. I almost read that. It looked like that was something that was moderated away before I could finish it. That was pretty funny. All right, so yeah, there's the hackathon. It's in our Discord if you guys want to join. Check it out. Check it out over there. So we're going to jump in. We're going to be doing some stock price predictions. We're going to be using the burn library and Rust, because Rust for everything, Rust for all of it. I think it's a good, I'm kind of excited because I've been using PyTorch for a little while. I like it. I like the simplicity of it. Let's jump into where we're at now. And then we will be done here. Oh, we've only been going for 5 minutes. Oh, 7. Okay, we can go 7 minutes. Okay. So we've got about 50 minutes. We got 50 minutes here, you guys. We got 50 minutes. All right. So what have we got here? This is where we're at so far. We've got our backend, which is running on Mac. So it's Metal backend, whether you're running, Apple Silicon or whatever video card you have installed in your system. And then we've got a couple of neural network layers, right? We got some layers. Are we using this layer config? What are we doing here? Oh, to instantiate a new layer. Oh, that's neat. All right, there we go. We're learning some new things here. Isn't that neat? I think it's pretty neat. Be careful, guys. This is not the speed or Kai stream, learn and fun or go somewhere. Wait, the last attack. Yeah. Be careful, everyone. Be careful, you guys. All right. So let's see here. I want to. So all right. So we got So we probably don't need more than one activation layer. Is that right? I guess we don't really need to create multiple ReLU layers, right? Based on this docs here, it shows that you only need one. So you could just do another self.forward here. We only need to define it once. So activation could just be this, right? Although, I suppose, where would we, I don't know. We'll keep it like that for now. Okay, so we need to do this part here. Let's do this part here. We'll do linear one, forward. Okay. Get rid of that. We don't need that. We're not using dropout. We're not using that. We are using activation though. And the activation is 1. All right. So we'll do that. And then we want to do that again. So that way that pops up as the same both cases as in our model here. And it looks like our output here, linear 3. Okay. So we'll add that as well. Here we go. To increase increment by 1. Thank you. Okay. And then we don't need any of these things. None of those things are there. We don't need that either. All right. Oh, wait. We need to return the last thing here. So we just return X, basically, is the idea. That's what we got to do. To be honest, I don't understand how many cores does Apple's M series chips have on the GPU. Well, they're all different, right? So a bunch of different the M chip series. They're like quite a few. Actually, let's find out how many GPU cores. I don't know. Let's see. Let's consult the internet on how many GPU cores Apple M. Let's do like an M4, for example. Let's do an M4. 10 GPU cores, but there are different configurations. Oh, so you could, if you get like the bigger chips, if you go like M4 Pro or M4 Max, you can get up to 40 cores. So that's a lot. That's a lot of cores, I assume. Although, I mean, it seems to, I assume it would be, because you hear in like the CUDA cores, you're in the thousands, right? So like NVIDIA gives you like thousands of cores. For, I guess, just like a personal computer, this is probably fine. That's probably fine, you guys. That's probably fine. All right, so the last layer will be layer 3. Forward, done, return, out. Okay. All right, so, whoa, image dim. So we don't need this. We don't need that. Okay. Forward, B, inputs. Wait. Where'd X go? Let me read. Where'd X go? Oh, X is gone. It's completely gone. We don't know what X is going to be. All right, width, height. All right, let's redo it all. So X is inputs. Basically, that's what. How about we do this? There. Well, no, we don't want to mutate it. Well, I guess we are because it's by reference anyway. So, all right. Variable shadowing. Just so I think we're good there. So 10 and dang 40. To be honest, those cores are low, and yeah, CUDA cores go crazy. They do, right? They go way crazy. Lewis, hey, how's it going, Lewis? Welcome in. Happy to see you. Happy Monday, you guys. All right, let's see. Let's see if we can get some stuff going on here. All right, so we've got our backend. Let's see if it runs cargo. Wait, ls. 1 second. I was thinking about doing something different here. So mv rust star to here. Ls. Oh, it didn't work. Okay. 1 second. Steven, don't click URLs. Okay, I won't click the URLs. Thank you for posting that. I definitely won't click the URLs. Thank you for posting. All right, so cd rust mv star to dot. Oh wait, 1 second. rm-rf.get. Okay, cd rust mv star to here. rm-dir rust. All right. Oh, come on. Oh, no. Oh, no. All right. That's not good. I hope I just deleted everything. Whoops. Whoopsie-doodles. All right. Git hub. Did I keep the project? Did I make it? Let me see if I can just start over. No, I didn't push it. Oh well, it's gone now. All right, I guess that's it. It's all over. All right, so I think we can recreate everything. We can recreate it. Let's see here. Let's see here. Let's see if it's stock. I'm looking to see. Nope. All right, it's gone. We deleted it, you guys. We just deleted all of the code. Whoops. Oh well. How long did it take you to be this good? Oh, Lewis? Well, I don't know if you... Are we this good? I mean, I just deleted the whole... All right. Vanishing quantified quantum. All right, sounds good. All right, let's see here. So, ls src. All right, so we still have the main rs at least, right? So we have to reinitialize everything. So, touch... See here. Cargo init stock... prediction, cd stock, ls, vi cargo, and then we need the burn library. Let's grab that really quick. All right, where's that at? It's around here somewhere. All right, we need to do cargo crates io. We go to burn. All right, burn library. The actual burn library, maybe. Here it is. This is the one right here. All right, and then we need features. Where's the features at? Features. All right. We need, what are we looking for here? We're looking for something. Let's see here. We needed to add like metal in for sort of features. Where is this at? Okay, so dependence. I know we're missing a part of it. All right, so let's close some of that. Let's clean some of that up. Do we need this? Let's see here. All right, I need to get the initialization. Just picking your brain. Let's see say the energy sector, which is seasonality. Can we bake in like news and how many barrels of oil we have daily to determine volume? Yes, you're right, Gishimain. You could absolutely do that. If you wanted to take all the inputs of all the varieties of like what's going on in the market, parallel markets, right? So commodities, you could add in there as well. You could add all that as variable data. You could add all of it. Isn't that neat? I think it's really neat that you can do that with AI. I'm actually pretty satisfied with that. All right, where is our cargo? We're missing, because we had it all like perfectly configured, and then I'm like, let's just delete everything. Whoops. All right, we'll get it back here. We'll get it back, you guys. All right, cargo. Where is I just need getting started. Okay. Where is the I need here, this is it. No. I need the cargo. I need the cargo features stuff here. You think it's around here somewhere? Let's see here. Cargo, let's see, burn, recursion. Nope. None of this. Is it in here? Where did we get it from? I'm sure we'll find it again here in a second. Okay, here we go. This is it right here. This is what we want. All right, we found it. Thank goodness. All right, here we go. Copy. Let's paste this in over here. All right. And then we need, was also, instead of web GPU, we need metal. I believe it was metal. All right, let's see. Cargo LS, hold on. Cargo build. Cargo build. Is it going to build? Did we do it right? Did we get it all back? I don't know, you guys. I don't know. It seems like it's kind of working. All right. Seems like we're doing okay here. All right. And then you just got to sit back and hope for the best. Although I did add quite a bit. So there's some of these things we don't need. We don't need all of these things here. Metal vision. We don't need vision. We need, I don't know what is TUI. What is TUI? I don't even know what that is. I don't know what TUI is. All right. So we have it in there now. We'll try to see if we can delete it. What do you mean? Wet hole? What do you mean? That's like what do you mean? What's wrong with my face? What do you mean? My face is fine, right? I think my face is fine. All right. So, let's see here. Tensor predicted, expected tensor found nothing. Okay. Forward. Oh, got it. Okay. Let's see here. It seems like, let's see here. Oh, got it. Okay. Forward model device. All right. Tensor. Oh, inputs is a tensor B2. Is it? Yeah, it is a B2. It needs to be B2. Expected B1, but found a B2. Oh, is it? In some of these things over here. Okay. See, this is where we're on. We're in new territory now. We got to figure out where this works. Implicitly returns empty as its body. It has no decay. Remove this semicolon. Oh yeah, right. We can do that. That's easy. That one's an easy one. All right. What? Oh, okay. Oh, what? Really? Oh, wait. Hold on. Yes. See, that's what we want. So we do have that, but however, it looks like we need to include some other stuff here. So use burn. Wait, is that how it wants it? Does it want it like that? Does it really? Expected struct found. All right. No, we don't need to do that. Okay. How do we go about this? Remove the semicolon as a. So I don't know. We're just gonna have to mess around with it until we find out. We're gonna have to mess around. All right. So okay. Model config 2. It should be. So model looks good. Okay. What language is this? Oh, Joseph. Hey, Joseph, how's it going? This is Rust. We're doing Rust. So we're trying the burn library. We're seeing how it goes. I don't know. We're seeing how it works. And we're going to give it a try. Although I want to go back to PyTorch really bad. I really want to go back to PyTorch. I think it's a lot more fun. So let's see. It's also more accessible and easier to deal with. As opposed to this. Look it on the screen. What is all this? Like, I don't know what to do. I don't know how to deal with this. Obviously, we could go consult the artificial intelligence, but that's the part where we're trying to learn. If we keep asking the AI, we won't learn. We need to figure it out ourselves. We need to struggle. That's what we got to do. We got to struggle. And then you remember. That's how you learn. You guys. All right, so now we are stuck-ish. Forward input B2. All right. You just returned the wrong super. Is that what it was? Is that all it is? So it needs to be a different super. So instead of 1, it should be 2. Expected, found. Oh, so it's got this. It's returning this, which is a linear. What is that return? So whatever this returns, that's what that is. So is it just a B, like that? All right, let's try that. It's better. We made one step closer. It's type Nevoke. Nevoke. All right. Thank you. Help me out, Nevoke. Don't go away. Stay here. B for block. Block us. How's it going? Block us. All right. So, D. All right. I don't know. D. Really? I don't know. See, this is weird. See, it does it always does this. Like, add this into the thing. Oh, okay. All right. How do we do this? Is it comma 2? All right. We'll try it. We'll try this. We're just messing around. If you guys know, is it all of a sudden good? Wait, no way. Hey, Quantified Malcolm, you're back. All right. You came back at a good time because it seems like we kind of brought back all the code I deleted accidentally. Oh, there it goes. Okay, it finished. All right. I don't know what that did. I really don't. I don't know Rust. I'm just a Python guy. Me mostly too from Python in an artificial intelligence perspective. Can you pause on the error message a bit so we can read it? Okay, cool. Hey, it's gone now. It's gone. You can't see it because we fixed it somehow. I don't know how we fixed it. I really don't know how we fixed it. We just started messing with it until it worked. So I guess we'll find out. All right, so forward, X forward. All right, so I'm guessing what we need to do is we need to actually use this now. So in the main. All right, so we have to find the model. All right, so then can we do model.forward? Is that what we do? What happened there was just types. It was just types. Okay. The compiler couldn't figure them out for you. That's it. Yep, that's one of the great things about the Rust programming language and the compiler is that it is very strict and it will do its best to help you out. And it kind of does a little bit, but it won't make sense a lot of the time. It won't make all the sense. Stephen, wave your hand. Okay, wave your hand if you are being held against your will. Oh, too late. Sorry, not waving my hand now. I waved it before I read the rest of your message. It was a little too much. A bit too much. Oh, let's see. Cargo run. Let's make sure it runs without blowing up. It worked. All right, look at that. All right, input and output is 2. Oh, output needs to be 1. Oh, wait. I see. Look right here. All right, so we found a problem already. I know, Torva. Whoops. All right, so how do we change the output? How do we do that? Is it right here in the linear? Number of classes. That's what it is. All right, number of classes. Where did we specify that at? Is there a default? How does it know? Model config. Okay, so model config right here. Oh, 2. Number of outputs. This has to go to... How do we specify the number of inputs? I guess we just... All right, so here's number of outputs. There we go. So this is why. All right, here, 1 second. Now we should get that. All right, cargo 1. That's not what I want. All right, that's not what I want. 1 second, you guys. 1 second. Gotta put that thing over here. I gotta press... All right. All right, so this is what I want, but it tells me no. It's telling me no right now. This library has a lot of generics. But yeah, I know, right? That makes it way harder for the average Python code. Like, so many generics. They're like generics everywhere. They're all over the place. All these capital single letters. So many generics, you guys. Fun to have. Nevok Python is recently moving and introducing more and more type, especially after 3. It is, right? Python is getting more type oriented. It is. And there's generics. I think the right because you passed 2 somewhere. Yeah, I did. I passed 2 right here because I want this to be the input, right? It's going to be two features, 1 label. 2 features, 1 label. We're going to try to make this as simple as possible. We're just going to do a hello world simple. Have you considered getting a cat? Yeah, I have. I have allergies. And so living with a cat is kind of like being sick all the time. And I like cats. Don't get me wrong. I like cats and animals, but I have allergies to them. And so having them in the house means that I'm always sick. It's not a great life for me. It's not a great life. I do like the animals though. I really do. Any optimizers you recommend for XGBoost on time series data? SGD has worked really well for me. And then Atom W. You could also use AutoGrad, which optimizes each of the parameters separately with separate learning rates. So you could do AutoGrad. I found AutoGrad also works pretty well, although I think SGD is just my favorite. Because it's nice and smooth, and it gives you pretty good predictable outputs. You need to try different ones based on all the different data that you have, though. So with your different optimizers, you need a slightly different. Try out each of them. That's what I recommend. Even AutoGrad might not work, right? AutoGrad might not be your best choice. You just want to try out a bunch of different things. These are like the hyperparameters, right, of your AI model. All right. So number of classes. I also want to say number. Can we do something else? Model config is just a struct. So where do we have here? Model config init. Okay. Is this no? See, because I'm using that here. So number of classes, number of inputs. So that's inputs. So num features, right? This is labels. This is number of features. Okay. So let's jump. Where do we have that? All right. So here we go. So we'll do number of features 2, number of classes 1, number of hidden units 128. See, here's the deal though. Can this work? Will this work? Oh yeah, because this is an init here. Okay. All right. We're starting to figure it out. Do any of them lean towards overfitting? Yeah, they do. So I think Atom W. I've seen, or what is it? There's another one. I'm trying to remember. The SGD tends to not overfit as much because it keeps things smooth. AutoGrad will also do a good job, though you can overfit on AutoGrad as well. You just need to get the right combinations of data. So you want to stop early. Stop training early and then test along the way. Run it through another epoch, test it again, run it through another epoch, test it again. And you can really, really get like an optimized model. Like you can really optimize the model. Linear 1 should use num inputs. Excellent. Thank you. Yeah, you got it. All right. Number features. Here we go. All right. So it'll be that self dot. There we go. Thank you. Thank you, Nevo. Is it Nevo Korean? I'm trying to say your name. I don't know how to say it. All right, so here we go. Doing okay. Didn't realize you used Rust. Nice. Hey, yeah, we use Rust. You're right. We got it. We like Rust over here. And we're starting to get okay with it. We've used Rust for many years. Don't get me wrong. It's just that using the burn library in AI with Rust is a whole new game. You have to learn everything. You got to learn over from the very beginning. Okay. So that's basically what we're doing. All right, so we got our model. We're initializing it back end. We got a default device, which is probably going to be CPU. We are probably going to want a to-do item here. So see, I'm like throwing in Python comments now because I've been using Python. Sorry. We want to do get GPU device. That's what we want to do. We'll figure that out here eventually. This is what we got to do. We got to get GPU device. Fun fact. Nixos is like having version control on your whole home directory, including home directory, on your whole root. That would be pretty nice because I'm accidentally deleting a bunch of things, though uncommon. I just did today. I just did that. I just deleted everything. Whoops. And so we had to recreate it all. Don't worry, it didn't take us long because we didn't get very far in the first place. All right, so let's see here. Is this going to, okay, expected 1, found 2. All right, so linear size. Where did it want that? On the linear 3. Linear 3 here. Okay, got it. Linear 3. But what about all the other ones? Let's see here. We'll get this. Hidden size. All right, number of classes, number of features, hidden size, looking good there. It's nice, but stuff does not work like Bevy. Randomly needing some weird things. Got it. Wait, so Bevy. Wait, let's check out Bevy. So, hold on, I'm gonna see this. Bevy Rust. Let's see, Bevy engine. Is it a game engine? I thought it was a game engine, right? Refreshingly simple, data-driven game engine built in Rust. See, this is the thing right here. Check this out. This is very important. Accessibility and simplicity is very critical when you're writing a framework. You want to make sure that it's very easy to develop with. Obviously, you want to add in flexibility. Don't get me wrong. You might want to add in like capability to do like with this burn library. It has a whole bunch of generics, which adds flexibility at the cost of complexity. It's too much. Bevity does not work in a Nix OS. Oh, okay, got it. Does not work. It looks like it works here on Windows, Mac, Linux, web. Oh, no way. So you could write all of your code in Bevy and it will work on all the platforms, including mobile. That's amazing. All right, Bevy's the way to go, you guys. Most Linux, nice, yeah. You have no idea what you're talking about. Most of the time, yeah. Most of the time, you never know. Yeah, Bevy is great. It looks amazing. So this is what I like. So let's take a peek at it really quick. I want to see some examples. The most important thing is when you're building a library is for sure to make it accessible. See, look at this. Oh, so nice. This is clean. This is very clean. I'm not seeing a lot of generics. I'm just seeing a lot of, looks like easy structs and enums and types. It's not a generic. It's just very specific, right? It's not a generic. It's specific. So this is nice. I like this better. This is very clean. Web GPU. Yep, you got it. By the way, Burn for the same reason works on the same platforms because of the GPU stuff. Oh, nice. Hey, I didn't know that. That's pretty nice. There you go. You guys. Okay. Sup. Hey, ID Legendary. I don't know how long you can be here. All right. At least you're here for a little bit. You're here for a bit. So also for me, we've got another. Let me check my clock here, because I do got to get going. We can only do 1 hour today here on our live, though it looks like we still have 30 minutes to go. So we've got plenty of time. All right. 1 second. Yes. Let's see here. 1 second. But you're aiming for it to be broader solution, right? Yes. Yes will work for everyone. And for more. Okay. We will need to do a rewrite. Let's see here. In Rust. Okay, perfect. All right. Next phase. Okay, perfect. All right, there we go, you guys. There we go. We did it. Are you training a model? Yeah, that's what we're doing. Yeah. Mar, we are absolutely 2 minutes to go. All right, quantified quantum. 20 minutes. Yeah, exactly. Eddie Legendary. 20 minutes. We've got about 25 minutes, so we're good. We're good to go. All right, let's jump over here. We are training a model. We are trying to get this generics to work. All right, so our simple typing. All right, so we just modified this struct, right? It's just its own struct, and then we're returning a model based on some layers. All right, a bunch of layers, and then so this is just very simple stuff. Very simple. I don't know what we're dealing with here, although we'll figure that out here in a bit. What is your specs for training? Hey, Mr. Tim Tom, how's it going? Good to see you. Welcome on back. We're specs for training. We're doing just it. You could do this all on CPU. You do not need a GPU for this. We're doing very small data. We will be doing stock quote data. What is the model supposed to learn? Price predictions, stock market predictions. That's what we're going to do because that's a lot of fun. It's easy. The reason why I like it is because there's a lot of data. Also, it's a little bit exciting, right? Isn't it a little bit exciting? Oh, hello. Good luck. All right. Thank you. Good luck. Thank you. I appreciate it. Me totally not building Legos. You're not building. Yeah, no. I see what you mean. Yeah. Over here trying to do stock market predictions with artificial intelligence in the Burn library using Rust. And we got Eddie Legendary tinkering with Legos. Thanks for explaining. Just got here. Hey, yeah, you're welcome. If you had any questions, let me know, you guys. We're going to make it work. So we're getting started with some... so we've got our metal backend. So it looks like that works. And then we've got our backend here. My backend type, my backend is going to be here. Oh, I get it now. I don't like it. But I get it. All right, so this is going to be metal backend. Here we go. Right, there we go. Dot. Done. Save. All right, so we get that going. All right, so that just helps me understand how the Burn library is working. Hey, Steve. Hey, Kamala. How's it going? Happy Monday. Good to see you. Welcome on in. Good morning. Yeah, the tensor currently marked as 1 in the output might be needed as 2. Okay, so tensor marked as output. Where is that at? Might be. All right, thank you for paying attention. Thank you, because there's definitely a problem here. We got a problem. This is the current problem. Let's rerun it. Double check. Okay. Thank you. The type. Okay. Batch 1. Oh, like the number mentioned is, so batch 1. Is it batch 1? Is that in the model that we're defining? Does it actually expecting me to provide batch sizes? Is it? Okay. So dimension. Okay. Let me see here. It's around here somewhere. All right, so hidden number classes, number features. All right, so model features. Okay, new model 1, 2, 1. All right, and the inputs. Where is this? So here's a config init. Is this positional? Like how does it know? How does it know this? Is it positional? Model new init. I don't get config. Oh, config. There's a derived config here, which is going to give us, I assume, this right here with an init. The init comes down over here. We can see the init is right here. We can see the init right there. No, like in init. Init's the type. Okay, got it. Okay, let's see here. It's off the screen. So we've got and device. Let's see here. All right, let's see. Let me bring this down so it's easier to read. Okay. So 2, 1, right? Number classes will be the number output. So look, number features 2, number outputs 1, right? So I'm assuming this is right, although it's clearly not because the compiler is like, nope. What is the theme color scheme? It's called Groovebox. Willie, it's called Groovebox. It is a, let's see here. Let me just, no? All right. It's called Groovebox. So just do a search for the color scheme and you'll find it. You'll find it if you do a search for the color scheme. 1 second. My chat window is all weird here. Oh, is it better now? Let's see here. Clicking. Wait. Oh, looks nice. Thank you. Hey, excellent. Thank you, Rab. Bro, why don't you use AI to code? I know, right? Claude Code Codex? Because we're doing it the hard way. Is what we're doing. We're doing it the hard way. This is the hard approach. Also, it's the way that you learn. So if you do it the difficult way, it's the best way to learn because it builds the neurons in your brains, right? Because it's like working out, kind of, right? You're struggling. You're struggling, and that struggle leads to retention. Because you don't learn by using AI. You got it, Torva. You got it. You do not learn by using AI. How's it going, System Forge? Hey, System Forge, how's it going? Good to see you. Happy you're here. We're doing stock price predictions today with Rust. All right, so on the last minute, expected burn tensor 1, found burn tensor 2. All right. See if we can figure this out. We will figure it. Okay, so here's the inputs. Let's do this. Bring that over. So here is actually what we could do is that. All right. So output is 1. Input is 2. Is that... so see, this should be fine right here, right? Because number of classes is supposed to be... this, I read it as good. AI codes adds more bloat than... Oh, it does. Yeah, it does. You're right. It does. Absolutely, Ralph. You got it, Ralph. But definitely still use it. Me too. Yeah, we still use it. Output should be 2. I don't want it to be 2, but we'll try it. We'll see. We'll see what it says. All right. 2. All right, you got it. You got it. I was right. You're absolutely right, but I need it to be 1. I need it to be 1. It's got to be 1, not 2. So how do we take care of that? No. It should be 2 because OTS, not number of classes. Oh, ID number of dimensions. Okay. I don't get it, but we'll try it anyway. So flatten. Yeah. Oh, okay. That's yes, I guess. I don't know. Is that what we got to do? Let's see. Let's just run it through. Let's run it through. Okay. So I would like to run the model dot forward. And then maybe we'll see if that works. All right. 1 second. No. This needs to be... Okay, here we go. So, dot. Can we just put dots in there? So that way it's... All right. Dot 0. We're going to make sure all... We're doing XOR. We're going to do XOR first. So that way we can make sure that this works. And the output needs to be a float as well. So we just got to put periods in there. We got to put little periods there. All right, perfect. All right, looking good there. Make it pretty. Making it pretty. All right, pretty. All right, pretty. It's pretty now. Like that, generic is basically the length of shape. So shape 211 would have 3. Okay. There are studies displaying the learning curve of people using AI, which displays, yeah, they learn, but these who don't use it grow exponentially since they can conclude things from the learning and knowledge of the learned knowledge. Yeah. All right, Torva, you're saying it right. You're basically saying that we're doing it the right way. That's what you're saying. That's what you're saying. All right. So here's our input data. Here's our output data. Sup, Steve? Okay. Hey, how's it going? Hello. Good to see you. Each plots. Is it each plots? Did I say your name right? Each plots? How's it going? All right. We're going to run it through and we're going to see what it looks like. Model.forward, tensor.data x. Let out equals. See if that works. Let's see if we can make that work. Let's see if that works. You're trying. All right. So it doesn't like that. Tensor. Oh, so we need to, how do we convert it to a tensor? Let's learn. Let's go to the docs. These stickers are killing me. What stickers? Oh, what stickers are you talking about? I might not be seeing them. They might not be showing up on my side. Let's see here. Burn library. Okay. Let's see. I need to. All right. None of that. All right. If my name too hard to say, I don't mind a nickname. All right. Let me know what your nickname. Let me make sure it's close. Each plots. Each plots is how I say it. Make sure it's close to at least what you have there. Lego. Oh, is it? Oh, and Lego. Okay, gotcha, Eddie Legendary. Understood. Example, please. Example. I need an example. All right. Linear forward. Okay. Yeah, that's it. Yep. That's not an example. That's just giving you some information. All right. So I need like a full example. Give me a full example, you guys. All right. Basic. Okay. That's not great. Documentation giving you a 404. Okay. Examples. Maybe. Oh, there's no examples. Creates source. Oh, they just immediately got rid of everything. Hold on. Burn. Are examples. Here we go. Examples. All right. Now we're in the right spot. I want to see something simple. All right. I know MNIST, so let's just start with that. Okay. Example. MNIST RS. Okay. All right. Torch G. Oh, you could use PyTorch if you wanted to. All right. libtorch. You could use libtorch. All right. That's neat. You can change the backend. All right. Pretty fancy. Getting fancy there. See you later. I have to go. All right. Hiking. Enjoy hiking. All right. Sounds good. We'll catch you guys next time. We'll catch you next time. All right. So we got 15 minutes. I think we can get something up and running by before then. All right. So CPU. Okay. So we got a bunch of different. Oh, that's kind of neat. Okay. CPU. So this is not at all anywhere near what I wanted. This is like nowhere near what I wanted. Like, what is this? None of this in here is giving me what I'm interested in. It's just a bunch of boilerplate. It looks like a bunch of different, what do you call it? I guess backends. It's got CUDA, Torch, GPU, C-ROM, a remote, which is neat. You could run it somewhere else. Look in source. Okay, we'll look in source. All right, so examples, Mimnist, source. Here we go, source. All right, let's do training. All right. Mnist training. All right. Number of epoch. Okay. Batch size, workers, seed, optimizer. Yeah, we still need an optimizer, so we'll have to grab that. Config optimizer. All right. We will want that. All right, so we'll deal with that later. I want to just do a forward. That's what I want. I want a model.fork. So model. Where do we see this here? Copy model. Model, please. I want the model. Thank you. Yes, the model. Okay, where's this at? Build. Linear builder. What's going on here? Oh, I don't like it. Might want to look in the model. Okay, we'll look in the model. All right, we'll check that out. Source model.rs. All right. Okay, so this is what we have right now basically in our current file. This is a bunch of convolutional neural network stuff, which doesn't matter because we've got, our own. We've defined our own forward. All right. So we've got the output looks good. Forward classification. So, okay. It's too much. It's like this is like not easy mode. There's so much code in here. It's ridiculous. Okay. So what is this forward here? Backend conv block. There's just a lot to it. Is this like a give up situation? I don't know. I'm feeling like giving up on this time around because I don't have that much time left here. And I really want it to work, although it's just, maybe there's a better example. Maybe there's something like a little easier to deal with. I just want something simple. Is there like a hello world? I need like a hello world. An easy one. Simple regression. Okay. I don't know if it's going to be simple. I don't believe it. I do not believe it. Okay, well, that's pretty straightforward. All right, so lib model rs. All right. Yeah, see, I figured as much. I knew it. I shouldn't have got my hopes up. I thought so. All right, so, I mean, this part's understandable. I get this part. Easy. We've got a bunch of imports. These are just structs that we're defining that are just going to hold information. Regression model, we've got an initialization, input layer, linear. Okay. And a regression model, which is... What is this? Okay. Oh, so this will be, okay. So that part's easy. I got that. All right. Forward. Okay. Yeah, you got to break the cycle. Just study, call learners, the psychological mechanism of fatigue and social buffering role of AI literacy. You can just say you will tackle it another day. I know, right? We can say we got somewhat far. Personally, having this much generics gives me a headache. I know, me too, right? It's like, come on, guys, let's get like easy mode, and then if you want, maybe they have like more advanced options that then offer generics. Like, why do they have to have so many generics? I wrote interfaces like 5 generics before. That's a lot of generics. Yeah, head clutter. It is. It absolutely is. You got it. Okay, so valid step, train step. Okay, let's see. Train step, regression output. For regression step, interesting. Forward, train output. So what are we looking at here? Let me see here. Let's see what else isn't. So interface. Come on. Okay. See, now, like, this is what I'm thinking. Like, we look at PyTorch, and you see how, like, in like maybe like 5 or 10 lines, you can have a full working model. And the easy model that's described here, simple regression, has nowhere near. I mean, obviously they're pulling in some charts, which is fine. Data loader and batching. Okay. What else we got here? Then it's just, I want an easier option, and we're not seeing it. It's like async. It goes everywhere. You got it, right? You got a generic. It's like, there's so much. Async await is fine. I like it because it makes the code so much easier to read. Although why couldn't it be like a default, right? Why can't async await be default? Need a Rust light with that syntax? That we do. Yeah, we do. Fractal cow. You're absolutely right. Easy mode, please. I want an easy mode. That's what I want. That's what I like. So we have something that is, built here. We got it. And it builds, or it used to build. So it'll build if we do this. If we get rid of this. Like, see, all I want to do is, no, we need that. We need not this. Here we go. Okay. So this will work right here. Don't worry about the warning. We're fine. We don't need to worry about the warning. Zig has some work on async that doesn't go everywhere. Oh, really? Neobec, that's great. That sounds phenomenal. I like that. Because it's less syntax, it's less work for the human, or I guess also less work for the AI as well, right? But with generics, got it. Okay. So you can do async await in Zig as a default with using generics. Got it. Okay. So I would like to so I've got my model here. I would like to just run a forward on it, right? So I've already got the forward here, right? Model backend. Here's the model. We've implemented forward. I just want to run that function. I just want to run it. That's all I want to do. I just want to run it. How do we do that? Let's see here. Let's just try X. Let's see here, X. Let's see if that works. Expected a tensor. All right, so we need to burn tensor. We need to create a tensor out of this. All right, so we need to convert X into a tensor. That's what we got to do. So let's see. Let X equals 10. So maybe that will work. I don't know. Let's see. That was autocomplete for us. All right. So metal backend to from data, the data X, which is X. Okay. So let's do input. Let's say input. All right. Let's see if that works. Is that going to be good? Nope. Nothing like it. Try into just like X into. Okay. We'll do that. Okay. Try into X dot into. Okay. Where is it? Right here. Into. All right. It might be. I might be. Data undeclared type. All right. So let's see. Data from. Trying things out here. It doesn't like that. WGPU device missing. Oh wait. WG. We're just using a regular device. What are you talking about? Metal. All right. Tensor right here looks good, right? Isn't it? Are we doing it right? Metal right here, right? We got the metal. Okay. Why does it want WGPU by cargo? Tummel. Let's see here. Train. See, right here. We're not using WGPU. Add and device as an input. Okay, we'll do it. Device. Okay. So we want to add that. Right. Oh, right here, somewhere here. Like array, comma device. Okay. There we go. All right, there we go. Here we go. Let me see here. All right, we'll just bring that down there so it's easy to read. All right, there we go. So that might do the trick, is what you're saying? We'll try it out. We're a step close. Wait, are we a step closer? No, we're farther off now. Like we're way out of there. It doesn't like that. Into must be a known at this point. Okay. Well, there we go. Basically, it needs to know where to put the thing. Yeah, that makes sense. Like so if we've got the data and we've got the tensor class. And the tensor class is going to need to know where is it going to put the memory. Is it going to put it on the GPU or is it into system RAM? My into suggestion was bad. All right, no worries. Into. All right. Let's try that. Oh, hey. Hey, it's building. Hey, there we go. Oh, so that was explicit data from. All right. There we go. All right. I'm actually feeling pretty good now. I'm feeling pretty good. Feeling pretty good now. All right. So let's do print out. Here we go. We don't need this anymore. All right. All right. We're getting good now. We're doing good. Hey, this is great. We have 5 minutes. Hey, Torben. Oh, it's working. It looks like it is. It looks like it. Oh, look at that. All right. Something happened. All right. So what do we got here? What do we got? All right. So this is a tensor. We've got the data, the inputs. Okay. So that was 100%. Perfect. Perfect. All right. This is perfect. 4 to 1, right? So it's a batch size of 4. The input size it should be like 421 basically is what it needs to be. At least for now. Let's go. All right. Neovec, thank you for your help. This is amazing. I appreciate your time here. Let's go. Let's do this. This is great. All right. Feeling a little bit better now. We got something that I'm familiar with, right? Getting a little bit familiar, like define the model when we shove data into it and we expect data out, right? Some data in and expect data out. All right. So can we do a slice? I want to do a slice. Let's see. Let's do a slice. Let's do, instead of input, right? So I want to only do part of the input, just a smidge. What's your time? It is 1 p.m. It's 1 p.m. And I've got a whole bunch of things to do because we got a lot of progress over the weekend with regular stuff. With business, you guys, we got some good business here. We got a lot of things to take care of. I wanted to spend some time with you guys, though, because this is a lot of fun. I love doing AI stuff, and I love doing Rust. Why not combine the two? The most difficult things in the world, I figured, let's merge them. Let's merge all of them. Let's merge them. Okay, I'm gonna do a slice. Let's do a slice on this. Can we do? How do we do slices in Rust? It's been so long. Slice in Rust. How do we slice? Is it exactly what I want it to be? It is. All right, there we go. That's what I want. All right, so let's do 0 to. Let's try. Let's do. Okay, so just try it. We'll just try to do this. 0.1. Let's just see if that works. Let's see if that works, you guys. You can just slice like it should in Python because that's how static arrays. Nice. Yeah, because it's static. You got it right. Static array right here. You're right here. It's immutable. I love the community. Me too. This is great. Thank you. Thank you, Neovec. Thank you. I don't know how to say your name. Oh, wow. This is real developer do. Respect. There we go, Fossil. That's what we're doing. Fossil, real developer stuff here for the most part. Oh, I didn't like that slice. Why not? Doesn't have a size known at compile time. Yeah, it does. Yeah, it does. It's right here. It's right here. It has a compile time size known. What is it talking about? The size for the values float cannot be known at compile time. Why not? It's got all the data. It's got, wow, this, no, okay, add a ampersand. Okay, we'll do an ampersand. Input, ampersand, okay. Oh, there we go. That's much better. Although require this bound, so there's something trait like, oh, wait, no, it didn't like it. The trait element is not implemented for float. Why not? It's just an array. Because it's the range is a runtime value. Got it. See, this is like one reason why Python is great is because you could just do that and it'll be perfectly fine. But with Rust, nope. If you wanted it to be different. All right. So can we do? All right. Let's bring that back. So at least we know we're in a known good state here. All right. Looking good. All of it good. All right. Good. Looking good. All right. So. C++ would have figured it out, right? C++ also would have figured it out. It's just that Rust. Sorry if me building Lego sounds childish. Hey, Legos are great. Legos are great for all ages, Eddie Legendary. There you go. Legos are fantastic. All right, so where else we want to go here? We've got a couple minutes left, and then I do got to get going. So I would like to slice this. I would like to just do one input. And then we'll do training tomorrow. So that'll be planned for tomorrow. So we've got this is the one thing that we did, right? Right here, this line right here. This line, it took so much time to get this line over here. It's ridiculous. I thought it was crazy. Maybe we could do let x equals input. Can we do like a slice? 0.1 right here, right? Input. Let's see. We're just messing around now, right? Can we do that? And then we say x equals... Yeah, we do something like that. Is that better? No, I don't think so. It's the same thing. Where it's just the same thing. Wait, semicolon. Okay. Let's see if that. Probably not. I don't know what to expect. Nebo. Okay. You coincidentally a quant dev, right? Isn't it? It's great. Nebo is here. It's great. Nebo is here and helping us out with this because the struggle. We're struggling. Okay. All right. All right. So here's the plan for tomorrow. Let's see, input, like that. Okay, plan for tomorrow is we're going to get the model to train. That's what we want to do for tomorrow. Tomorrow's stream, we'll get the model to train. We did a feed forward. It looks like it's working. I like this output data here. This is the part that I'm familiar with. I get that part right there. That's the part that I get. I like this part right here. Honestly, the fact of doing and input does not figure it out, right? It should. Nevo, it should, right? Did some AI papers way back. Nice. Very nice. This is very beneficial. Right now, you're doing a degree in writing programming languages. Ooh, very nice. Writing your own programming languages. There's a challenge there. If you want some hard mode stuff, you got it. There's some hard mode. Hey, why is it back-end web GPU? Oh, MSL. Okay, got it. So this must be the metal here, and then the web GPU, and then, okay. I guess. I don't know. We'll mess around with it more. All right, so the plan for tomorrow is, so we got to get going. You guys, thank you for hanging out. So yeah, Burn wrote the code not well enough there. It seems like it. Yeah. Because it would be nice to be able to do some of these things that we can't seem to be able to do. It certainly would be nice to be able to do some of those things. Okay. All right, there we go. All right, so it's nice and pretty. Actually, we could bring this back over here real quick. Let's bring this back. I want this to align nicely. All right, that aligns. All right, that aligns nicely. Okay. This is why slice is broken. Is it? Got it. You're 100% not wondering, but what I was building the Supra MK4 Fast and Furious Lego set. Nice, Eddie Legendary. There you go. What time do I go live? Usually, Meso, is between 10 a.m. Pacific and 2 p.m. Pacific. So it's around that time. Around this time. Yep, you got it, Eddie Legendary. You got it. All right, you guys, we got to get going. Thank you for spending time with me today. We had some fun with Rust and some AI the Burn deep learning framework, which was great. It did what we wanted it to do, but not really. Not really. I wanted it to do a lot more. We understand it a little bit better now. We see here that we've created our own class and our own, we're implementing an init function, which is fine, that's regular, and we're returning a model, which gives us basically another, well, I don't know, model here. Where is this? Okay, so we've got our own struct here. Okay, so we've got multiple structs. What I would like to do is probably bring some of this stuff up. Well, yeah, whatever. Let's bring this up here at the top. I think it's a little bit nicer, so that way we can see what's happening. By the way, Stephen, have you considered a cat that doesn't trigger allergies like the Berman? Yeah, there's hypoallergenic cats. Chris Arts Codes, how's it going? Yeah, we're headed out now. We got to get going. Bye, nice stream. Cool, Eddie Legendary, thank you. Glad you had fun with Legos and watching the stream. Yeah, Torva, so there are hypoallergenic cats that I've been considering, though I would have to try it out, basically, to see, because they're not like 100% allergen-free, right? They are mostly allergen-free. So it might be good enough, or it might not be. I don't know. We'll just have to try it out. I've never done it before, but we'll see. Like a Berman, the Berman cat, right? Berman cat. Where does that look like? Wait, really? Wait, this cat is hypoallergenic? This cat right here, you guys? This cat right here? Is it? Is it allergen free? Berman, are Bermans expensive? Yes. That's too expensive. That's expensive, you guys, for a cat. And then it's like, cat, you better be worth it. like, oh, very expensive cat, you guys. Wow. They're completely bold cats. Yeah, they are. Nice. All right. 20 more minutes. I know, right? 20 more minutes. All right, we got to get going, everyone. Thank you for hanging out today. It was a lot of fun. We will be doing more Rust and the Burn framework tomorrow. It would be great to get the model to train on the input and output data. That would be really nice. I would very much like that. And then we need to get the download stock data, and then we'll see if we can train the model to learn the stock data. We'll find out. We'll see if it works. Same hour? About the same hour. Let me double check. 1 second. I will check the calendar. Tomorrow. Oh, wow. Okay. Yeah, about the same time. Yeah, cool. All right, same hour. There's Sylvia or saliva. Oh, saliva. Don't have the allergens in their saliva. Oh, yes, gotcha. Yeah, that's where the allergens come from. All right, you guys, thank you for hanging out. It was great to spend time with you today. We're doing some Rust and our Burn library for deep learning AI frameworky goodness, which okay, it's fine. It's not my favorite. We seem to have got it to work with the help of Nevo here. Thank you, Nevo, for your help. It was great. We're going to be back tomorrow. It was great to see you guys. See you all tomorrow. It's been a pleasure. Yep, it has. It's been great. Thank you guys for hanging out. We'll see you guys tomorrow.